Welcome to Next Gen Manufacturing. Today, we're diving into something that sounds incredibly small, but its story is huge. We're talking about the drop hole dilemma. It's a perfect example of a classic engineering puzzle that forces a choice between raw efficiency and absolute safety. A choice that reveals a ton about the smart, tough decisions happening in modern manufacturing right now.
So, here's what we're going to cover. First, we'll tackle a really common problem, machining a perfect O-ring groove. Then, we'll look at the clever trick engineers came up with, the drop hole, and see just how much faster it can make things. But here's where it gets interesting. It's not a silver bullet. We'll get into the risks, the strict rules for using it, and what this whole dilemma tells us about the next-gen manufacturing mindset.
Okay, let's kick things off with the O-ring groove challenge. You might be thinking, an O-ring groove? Come on, how hard can that be? You just cut a little trench for a rubber ring, right? Well, when you're dealing with the physics of cutting metal, things get a lot more complicated than they look. So what's the big deal? Why is this so tough? Honestly, it all comes down to the tool. See, to get that specific undercut shape an O-ring needs to sit in there just right, your average tool won't work. You gotta call in a specialist.
And this is the guy for the job, the dovetail cutter. Just look at that shape. It's perfectly designed to create that special groove. But you probably see the problem already, right? The part that does the cutting is wider than the neck of the tool. That means you can't just plunge it straight down into the metal. And that one single design feature, well, that's where all the trouble starts.
So if you can't go straight in, what do you do? Well, this is where engineers got clever. This is where we get the drop hole solution, a super simple but totally brilliant workaround. And a drop hole is, well, it's pretty much exactly what it sounds like. It's a hole you drill beforehand, a little off to the side. Its only job is to create an entry point, a little landing zone, for that dovetail cutter to drop right into so it can start moving sideways and do its thing.
Now, here's why that simple hole is such a big deal. Because the cutter doesn't need to squeeze in anymore, you don't need a tool with a skinny, weak neck. You can use a much bigger, beefier one. And in the world of CNC machining, a stronger, more rigid tool is a total game changer. And using that stronger tool kicks off this awesome chain reaction of good things. A beefier tool can take much bigger bites out of the metal. That means you need way fewer passes or step-overs to finish the groove. Fewer passes means a faster production rate, simple as that. And, as a bonus, the tool isn't working nearly as hard, so it lasts a whole lot longer. It's a win, win, win.
All right, talk is cheap. Let's put some actual numbers to this. This is where you'll really see the massive impact of adding one little hole.
First, let's look at the old school way, no drop hole. You're stuck using that weaker, skinnier tool, which means it has to take these tiny, careful little nibbles at the material over and over again.
And those tiny nibbles really add up. We're talking up to 20 separate passes on each side of the groove just to get it done. 20! That's a ton of machine time, a lot of wear and tear on your tool. It's just plain slow.
Okay, now let's flip to the next-gen method. We add that one simple drop hole and suddenly we can bring in the heavy hitter, that stronger, more efficient cutter we were talking about.
And the result? Now we're looking at a maximum of just 4 passes per side. Let that sink in. We went from 20 down to 4. That's not just a little improvement. That is a massive leap in efficiency. I mean, just look at this comparison. It really puts it into perspective, doesn't it? That's a 5-fold reduction in the number of passes. Now, imagine you're in a factory making thousands of these parts. The time and money you save is absolutely huge. It's a revolution.
So the obvious question is, if this is so amazing, why doesn't everybody do it all the time? Well, like they say, there's no such thing as a free lunch. That incredible efficiency comes with a potential cost, and sometimes that cost is just too high. Here is the catch. That helpful little hole we drilled to let the tool in, it stays there. It creates a tiny gap, an interruption in what should be a solid, continuous wall. And that little gap, that engineered feature, can become a weak spot. Under the wrong conditions, that's where your seal can fail.
And that risk is a complete non-starter in certain applications. You would never use a drop hole in a high-pressure system where a leak could be catastrophic. You'd avoid it for any seal where failure is just not an option, like in aerospace or medical equipment. And obviously, you'd never use it in a system with hazardous fluids. Really, at the end of the day, you should never even consider it unless the customer has explicitly approved it. Okay, so let's say a drop hole is approved for a job. You can't just drill it anywhere you want. To make sure that seal is as strong as it can be, placement is absolutely everything.
And it really boils down to 2 golden rules. Rule 1, you always place the hole off-center. That way, you're only interrupting one wall of the groove, leaving the other side perfectly solid and fully supported. Rule 2, and this is the really clever part, you place that hole on the high-pressure side of the seal. This way, the pressure actually helps you out. It literally forces the O-ring away from the gap and presses it firmly against that uninterrupted solid wall, helping to create a secure seal.
So let's zoom out for a second. What is this one super specific technique, this whole drop hole dilemma? Tell us about the bigger picture of next-generation manufacturing.
It really comes down to this fundamental trade-off, what you could call the expert's dilemma. On one side of the scale, you've got all the pressures of efficiency. You need faster production, lower costs, longer tool life. But on the other side, you have the non-negotiable demands of integrity, uncompromising safety, higher reliability, and mitigating every possible risk.
And that, right there, is the next-gen mindset in a nutshell. It's not about just having the flashiest machines or the newest software. It's about having the wisdom and the experience to make these smart, nuanced decisions. It's all about walking that tightrope between efficiency and absolute, uncompromising safety.
So I'll leave you with a question to chew on. As technology continues to race ahead, where do you think the next big manufacturing breakthrough will come from? Will it be something that pushes efficiency even further, or will it be a new way to guarantee integrity and reliability? The answer to that is going to define the future. Thanks for watching.